NASA says that Voyager 1 has become the first man-made object to reach interstellar space, the cold, dark region between stars.
After more than 4 decades of silent drifting through space, NASA's Voyager spacecraft finally reached the edge of the solar system, and what they found wasn't quiet. Instead, they picked up something eerie. A persistent hum, plasma waves behaving like living things, and magnetic fields doing the opposite of what science predicted. The data stunned NASA.
Voyager 1 probe.
The Voyager 1 probe.
To once again have meaningful conversations with Voyager 1.
And now, with new updates from Voyager 1 and 2, the mysteries are only getting deeper. What's new out there? Incredibly, more than 46 years after their launch, the Voyager spacecraft are still transmitting data back to Earth. That alone is a feat of engineering wizardry. But even more astonishing is what they're actually detecting now. At the edge of our solar system, in the icy no-man's land between stars. NASA thought Voyager would pass into silence. Instead, it's been feeding back some of the strangest signals ever recorded from space. In 2024, Voyager 1 gave scientists a bit of a scare. For months, the data it sent back was garbled, unintelligible strings of information that looked more like a glitch than a transmission. Engineers feared the worst. Had the spacecraft finally succumbed to age and cosmic radiation? Then, in a last-ditch effort, the Voyager team tried something bold. They rerouted commands through an unused part of the spacecraft's memory, like performing brain surgery on a robot built with 70s tech. Incredibly, it worked. In April 2024, clear data began streaming in again. Voyager 1 was alive, and it was talking. What it said, though, left scientists speechless. Out beyond the heliopause, the boundary where the sun's influence fades, Voyager detected something strange. A low, persistent hum. It wasn't radiostatic or a malfunction. This was real. A plasma wave emitted from the interstellar medium itself. It's constant, faint, and unlike anything inside our solar system. Scientists expected the space beyond the solar system to be mostly empty, a cold, dark vacuum. Instead, it's alive with subtle motion and eerie sound. The hum isn't just weird. It's impossible to ignore. Even more curious is what Voyager is finding about magnetic fields. As Voyager 1 crossed the heliopause in 2012, NASA expected the magnetic field direction to flip. Instead, the field barely changed at all. This completely upended assumptions about how our solar system interacts with interstellar space. Initially, some scientists thought Voyager might be mistaken, or that its instruments were malfunctioning. But in 2018, Voyager 2 crossed into interstellar space as well, and confirmed it. The magnetic field really didn't behave as predicted. Whatever is happening out there, it's far more complex than anyone imagined. Voyager 2 didn't just confirm the weirdness, it amplified it. As it entered interstellar space, its instruments picked up plasma that was even denser than Voyager 1 had reported. The environment wasn't thinning out as expected, it was getting thicker. And once again, the magnetic field seemed to curve and twist unpredictably. Both probes, launched over a decade apart, are now sending back remarkably consistent data. Space beyond our solar system isn't dead. It's dynamic, it hums, it pulses, and it's full of secrets. But perhaps the most mind-bending realization is this. Interstellar space isn't out there in the way we once thought. It's right at our doorstep. Voyager didn't enter some distant alien realm. It stepped just a little past our solar border and found an environment that's already starting to push back against the sun's influence. This means our solar system's edge might not be a clean boundary, but a blurry, shifting zone where the rules change. And the more Voyager tells us, the more it raises the question, what else have we misunderstood about the edge of our own cosmic neighborhood? The Great Solar Shield. Cracks in the heliopause. For decades, scientists pictured the edge of our solar system like the walls of a fortress, a clean, protective boundary where the solar wind, that constant stream of charged particles from the sun, finally lost its grip. This outer wall is called the heliopause, and it was long believed to be our first line of defense against the chaos of interstellar space. Voyager, however, has revealed something much more unsettling. The wall is cracked. Maybe it was never really a wall at all. Let's start with what the heliopause is supposed to be. The sun doesn't just give us light and warmth. It also blows a bubble of influence called the heliosphere, a kind of invisible shield made of magnetic fields and solar particles. This bubble extends far beyond Pluto, and the outer edge of that bubble, the heliopause, is where the sun's power ends and the galaxy begins. Until recently, scientists imagined this boundary as a sharp divide, a sort of cosmic shoreline where solar winds crashed and halted against interstellar waves. But when Voyager crossed that line, the data told a completely different story. First, there was pressure, far more than expected. Voyager found that the interstellar medium was pushing back harder than models had predicted. That alone rattled scientists. It was as if the vacuum outside wasn't passive at all, but alive, resisting the sun's expansion. Then came the particle readings. Instead of a clean cutoff, high-energy particles from beyond the heliosphere were leaking in. Worse, some of the sun's own particles were escaping out. The heliopause, it turns out, is not a sealed barrier. It's more like a sponge or a sieve, porous and unpredictable. This is more than just a fun fact for space nerds. These particles matter. Many of them are galactic cosmic rays, ultra-high-energy radiation from exploding stars and other violent cosmic events. They're capable of slicing through DNA and electronics alike. Normally, Earth is shielded by our magnetic field and atmosphere, and the solar wind helps deflect many of these rays before they even get close. But if the heliopause is compromised, or weaker than we thought, more of these rays could start creeping in. Voyager also found that the heliopause isn't static, it breathes. When solar activity ramps up during a solar maximum, the heliosphere swells. During solar minimums, it contracts. This means the heliopause moves, it wobbles, and in some directions, it might even fold or tear. In fact, some data suggests Voyager crossed the heliopause multiple times, back and forth, before finally settling into interstellar space. It's not a wall, it's a tide. And here's the kicker. The heliopause may already be weakening. The sun is in a relatively calm phase right now, but it's possible that in the future, especially over cosmic timescales, the solar wind could diminish further. That would mean our solar bubble shrinks, and Earth becomes more exposed to the raw fury of the galaxy. Some researchers are even investigating whether historical increases in cosmic ray exposure on Earth, which might correlate with climate events or even mass extinctions, could be tied to shifts in the heliosphere. So, what Voyager revealed wasn't just a new perspective on the edge of the solar system, it was a warning. The solar shield we thought was rigid and protective turns out to be flexible, leaky, and far more fragile than anyone imagined. And that leads to the next big question, because if space beyond the solar system is so active, and the barrier between us and it is so thin, what exactly is going on out there? The alien signal that wasn't. In May of 2021, Scientists analyzing data from Voyager 1 noticed something strange. While combing through plasma wave readings, essentially measurements of the behavior of charged particles in space, they stumbled upon a signal. It wasn't a burst or a blip. It was a steady, low-frequency hum that had been quietly singing through the void since the probe crossed the heliopause. The first reaction? What the hell is that? It wasn't an equipment error. It wasn't feedback from Earth. It was real. A background vibration, subtle but persistent, emerging from the interstellar medium itself. This wasn't just noise. It had structure. Scientists called it a narrow-band plasma wave emission. But let's be honest, space hum is catchier and spookier. Cue the headlines. Voyager detects mysterious signal from deep space. On social media, the theories flew fast. Was it aliens? A cosmic beacon? The background soundtrack to the universe itself? While NASA and the scientific community quickly clarified that no, it wasn't a message from an alien civilization, the truth was still wild in its own right. This signal is coming from interstellar plasma, charged particles that drift between the stars. And while plasma waves aren't rare, the continuous narrow-frequency Voyager detected was not what scientists expected. It's like turning on a radio in a completely silent forest and hearing a steady, faint song playing from nowhere. The real shock was not that something was out there, but that it was so consistent. Plasma emissions usually fluctuate based on solar activity, but this tone didn't change. It didn't pulse. It didn't fade. It just kept humming. That raised all sorts of new questions. Is this a feature of all interstellar space? Is Voyager just lucky, or unlucky, to be passing through a particularly weird patch of the galaxy? Or is this the background noise of the universe we just never knew existed? NASA scientists had no immediate answers, just lots of theories. One possibility? The hum is the result of interactions between interstellar plasma and the faint echo of our own solar wind, like two overlapping weather fronts creating a never-ending storm. Another theory suggests it's tied to shock waves from ancient supernovae, now traveling like slow-motion ripples across the Milky Way. Whatever the source, the implications were massive. First, it meant that interstellar space isn't the silent vacuum we imagined. Second, it proved that Voyager 1's instruments, decades old, running on less memory than a digital watch, were still capable of capturing data that challenges our deepest assumptions about the cosmos. And third, it hinted at the possibility that space itself is more connected, more dynamic, and more mysterious than we ever dared to dream. Of course, NASA had to do damage control. The phrase "mysterious signal from space" has a way of spiraling into alien speculation. And while scientists insist there's no evidence of intelligent life behind the hum, the public fascination was telling. Deep down, many of us want to believe the universe is speaking to us, or at least whispering something in the background. Still, even without aliens, the discovery was haunting. Imagine being 14 billion miles from Earth, utterly alone in the blackness, and hearing a faint, persistent sound. Something the universe itself seems to be humming. No message, no rhythm, no language, just presence. A reminder that the void isn't empty. It's full of currents and whispers, and maybe, just maybe, secrets we haven't yet unlocked. Voyager didn't stumble across alien intelligence, but it did reveal a kind of cosmic intelligence of a different sort. A symphony of forces, invisible and ancient, humming across the galaxy. And it's only because of one aging spacecraft, still crawling forward in the cold dark, that we even know it's there. And here's the strange part. The farther Voyager travels, the louder the universe seems to get. Into the unknown. Before Voyager, interstellar space was thought of as the final great silence, a cold, dark vacuum so empty it was practically nothingness, a place where even light takes years to travel, and particles are so rare you could go miles before hitting just one. But as Voyager 1 and 2 crossed the heliopause, they shattered that myth. What they found wasn't a quiet void. It was a realm full of motion, density, and structure. Space beyond the sun's reach isn't dead. It's weirdly alive. One of the biggest surprises? Plasma density. Scientists expected that once the spacecraft exited the sun's sphere of influence, they'd enter a region where particle density dropped off a cliff. Instead, they found the opposite. The plasma in interstellar space was actually denser than what Voyager had just left behind inside the heliosphere. This flipped decades of models on their heads. Why would a region so far from stars and energy sources be more packed with charged particles? It turns out, the interstellar medium, the vast ocean of material between stars, isn't as thin or quiet as we thought. It's filled with drifting clouds of gas and plasma, likely remnants from ancient supernovae or the outflow of other stars. These clouds are slow, cold, and eerily quiet until you pass through one. Then, suddenly, things start to stir. Voyager's instruments picked up shock waves, ripples, and fluctuations in particle pressure, almost like the spacecraft had entered some kind of weather system. Yes, interstellar weather. That's now a real thing we have to consider. Even more bizarre, Voyager detected miniature shock waves, tiny echoes of violent events that happened millions of years ago. These aren't the thunderclaps of exploding stars, but the distant, faded rumblings of energy still drifting through the cosmos like the aftershocks of a long-dead earthquake. One such event, recorded by Voyager 1, lasted several months and caused a noticeable spike in plasma density. These kinds of findings make one thing crystal clear. Interstellar space is not uniform. It's not one endless gray soup of particles. It has texture, structure, variability, and Voyager just happened to drift through a particularly active patch. There's also the matter of the sun's fading echo. Even though both Voyager spacecraft have passed into interstellar space, they're still able to detect traces of solar activity. Solar storms from years ago, launched outward by massive coronal mass ejections, can travel for billions of miles and still be felt by these tiny spacecraft decades later. It's as if the sun is still whispering to them across a vast, stretching distance, its voice faint but not gone. This raises another fascinating question. How far does the sun's influence really reach? The heliopause might mark the technical boundary, but Voyager is showing that traces of solar wind and solar magnetism extend far beyond that. The sun's fingerprint lingers. It's not a wall we hit and exit. It's a fading gradient, like walking from sunlight into dusk, where the light doesn't suddenly vanish, but fades slowly, almost imperceptibly. And yet, for all this complexity, Voyager is just scratching the surface. It's still within the local interstellar cloud, a relatively tame region of space the sun has been drifting through for tens of thousands of years. In another 20,000 years or so, Voyager will leave this cloud and enter a new region. If it's still functional, and let's face it, that's pure science fiction, who knows what it might find? Denser clouds? Rogue magnetic fields? Pockets of energetic particles from long-lost stellar cataclysms? The key revelation is this. Space between the stars is not empty. It's unexplored. For centuries, we've treated it as a featureless backdrop to more interesting things. Stars, planets, galaxies. But now, thanks to Voyager, we're seeing that the so-called in-between is just as rich with mystery as anything else in the cosmos. And that mystery feels all the more profound when you realize it's being revealed to us by two tiny probes, built with rotary phones and slide rules, hurtling alone into the dark. How a 1977 probe is still talking to us. It's easy to get lost in the science, the plasma waves, magnetic fields, interstellar hums, but let's take a moment to appreciate something just as miraculous. These spacecraft are still alive. They were launched in 1977, before the internet, before cell phones, before most of the planet had even seen a personal computer. And yet, nearly 5 decades later, Voyager 1 and 2 are still transmitting data from billions of miles away. That's not just science, that's wizardry. To put it in perspective, Voyager 1 is now over 14.8 billion miles from Earth, and Voyager 2 isn't far behind. The signals they send take over 22 hours to reach us, traveling at the speed of light. And they're not using high-tech laser comms or cutting-edge quantum devices. They're using a 20-watt transmitter, about the power of a refrigerator light bulb, to whisper across the cosmos. And somehow, NASA is still able to listen. These spacecraft were built with late 70s hardware. Their computers have less memory than a digital watch. They store commands on magnetic tape. The processors run at a speed slower than your microwave's display chip. There are no backups, no spare parts, and yet they've endured cosmic radiation, freezing temperatures, micrometeoroids, and the yawning, stretching vacuum of space, far longer than anyone thought possible. Behind the scenes is a small, fiercely dedicated team of engineers and scientists, most of whom weren't even born when the probes launched. Many work out of NASA's Jet Propulsion Laboratory, where the original blueprints are stored, on paper, in filing cabinets. When a problem arises, and they do, it's not as simple as hitting Control plus Alt plus Delete. Engineers often have to dig through decades-old documentation, handwritten notes, and outdated code just to figure out how a system works. One of the most jaw-dropping examples came in late 2023, when Voyager 1 started sending back corrupted data. For months, it was gibberish. Scientists feared the probe's aging systems had finally succumbed to deep space. But in early 2024, the team pulled off a stunning save. They identified the faulty chip in the spacecraft's flight data system, rewrote its software, and rerouted commands to a different memory bank, a part of the computer that hadn't been used in over 40 years. Imagine performing brain surgery over 14 billion miles away, without being able to see the patient, and waiting almost a full day to find out if your first incision even worked. That's what the Voyager team did, and they pulled it off. Of course, these fixes can only hold for so long. The real enemy now is power. Both spacecraft run on radioisotope thermoelectric generators, RTGs, nuclear batteries that convert heat from decaying plutonium into electricity. But that power source is fading. Every year, they lose about 4 watts. Systems are being shut down one by one. Heaters, science instruments, backup thrusters. It's like a life support machine slowly powering down. NASA estimates that by 2026 to 2030, both Voyagers will likely go silent. When that day comes, they won't crash or explode. They'll just stop transmitting. Their antennas will stay locked in place, their instruments will fall cold, and they'll drift forever through the Milky Way. Silent ambassadors from Earth, relics of a civilization that once reached out to the stars with nothing but curiosity and a golden phonograph. And yes, let's not forget the golden record. Both Voyager 1 and 2 carry a gold-plated copper disc, literally a 70s-style LP record containing images, sounds, music, and greetings from Earth. It was a message in a bottle, launched into the dark, in case someone or something out there ever found it. Carl Sagan famously called it the story of Earth from far away. Even if Voyager goes silent, that message will remain, floating through space for potentially billions of years. So the next time you hear about some high-tech space telescope or a Mars rover, spare a thought for the two oldest space travelers of all. Voyager 1 and 2 aren't just spacecraft, they're endurance legends. And every byte of data they send is a miracle. The big picture. It's tempting to see Voyager's discoveries as distant curiosities, cool facts from far-off space. But that would be missing the point. The hum, the plasma waves, the magnetic surprises, the leaky heliopause, these aren't just sci-fi oddities. They matter right now, and not just for astrophysicists or NASA engineers. They matter for Earth, for future space missions, for our long-term survival as a species. Voyager isn't just changing what we know, it's changing what we need to think about. First, the obvious. Voyager has forced scientists to redefine the edge of the solar system. For decades, we assumed it was a tidy cutoff. The sun's solar wind ends here. Space begins there. But now we know the boundary is a mess, shifting, breathing, full of turbulence. The idea that we can point to a map and say, here's where it ends, just doesn't hold up anymore. Space, like Earth, is more complicated up close. Voyager showed us that the edge is more like a fog bank than a fence, and that means any future spacecraft heading out there will need to be ready for a lot more unknowns than we expected. But it goes deeper than cartography. The heliopause isn't just a line, it's a shield. And if that shield is weaker, leakier, or more unstable than we thought, then our entire understanding of how Earth is protected from deep space radiation has to evolve. Cosmic rays aren't just distant threats. They can affect climate, electronics, even human health. If our solar shield weakens over time, as it inevitably will, Voyager's data might one day help us prepare for a planet more exposed to the galaxy's raw forces. Then there's the future of exploration. The interstellar probe, a concept NASA is studying for the 20s, is inspired directly by Voyager's success. That mission would be faster, more targeted, and built specifically to study interstellar space. But it's Voyager that gave us the roadmap, or at least showed us that the road exists. Without it, we'd still be guessing what lies beyond Pluto. Now, we're planning missions with the confidence that comes from actual, ground truth data. Voyager also sparked new questions about our place in the galaxy. We used to think interstellar space was boring. Now we know it's teeming with complexity. That opens the door to new physics, new models of stellar behavior, and even questions about habitability. Could certain interstellar regions protect planetary systems better than others? Could pockets of dense plasma or strong magnetic shielding help shelter life in places we never considered? And of course, there's the psychological angle, the poetic one, the one Carl Sagan captured so well with his pale blue dot speech. Voyager 1 took that now iconic photo of Earth from nearly 4 billion miles away, just a speck of dust caught in a sunbeam. That image, more than any scientific data, reframed humanity's self-perception. It reminded us how fragile and tiny we are, and how deeply connected we all are, floating together on this little rock in a vast, humming sea. Today, with climate challenges, geopolitical tensions, and cultural divisions, that perspective is more urgent than ever. Voyager reminds us that we're not just nations or tribes, we're a single species, riding the edge of a very small bubble in an enormous universe. And that bubble, we now know, is far more fragile than we once believed. Finally, Voyager represents a kind of cosmic optimism. In a world obsessed with speed, novelty, and instant gratification, here's a pair of spacecraft that have taken nearly 50 years to show us the truth of the space we live in. They're slow, outdated, running on borrowed time. And yet, they are still revealing brand new mysteries from billions of miles away. It's a reminder that discovery doesn't always happen in fireworks and fanfare. Sometimes it hums quietly in the background, waiting for us to listen. What Voyager found shocks NASA, but it should also shock us. Because in the cold, silent dark beyond our solar system, the universe isn't still. It's whispering, tugging, singing. And thanks to two aging machines, we finally have the ears to hear it. How this mission is shaping tomorrow's space dreams. Voyager's story isn't just a tale of discovery. It's a beacon lighting the path for the future of space exploration. When those two golden probes launched in 1977, no one could have predicted just how profoundly they'd shape our cosmic ambitions decades later. The discoveries at the edge of the solar system, unexpected plasma waves, magnetic surprises, and that mysterious interstellar hum have done more than rewrite textbooks. They've ignited fresh questions and ambitions. Scientists and engineers now look to Voyager's data as a blueprint for designing the next generation of spacecraft meant to venture deeper into the unknown. The proposed interstellar probe mission, inspired directly by Voyager's bold leap, aims to travel faster and farther, with modern instruments to map the interstellar medium in unprecedented detail. Voyager showed us what lies beyond the heliopause. Now, the new wave of explorers is figuring out how to study it systematically. But beyond science and engineering, Voyager's legacy touches something deeply human: the enduring spirit of curiosity. It reminds us that exploration isn't about instant results or flashy launches. It's about patience, resilience, and a hunger to understand our place in the universe. Voyager's journey challenges every future mission to dream bigger, plan longer, and embrace uncertainty. In an era dominated by quick returns and immediate gratification, Voyager stands as a testament to slow, persistent progress. Are we finally listening? Voyager wasn't supposed to last this long. It wasn't supposed to make it past Saturn, much less leave the solar system. And yet, here we are, nearly 5 decades later, still receiving messages from two lonely spacecraft hurtling through the void. They've gone beyond the known, beyond the expected, and beyond the limits of what we thought was possible. And the universe? It didn't greet them with silence. It greeted them with a song. The persistent hum of plasma waves, the dense, shifting interstellar currents, the magnetic fields twisting in ways we never predicted. Voyager didn't just cross into another region of space, it crossed into a new era of understanding. What we once imagined as empty is now known to be complex. What we believed was a boundary turned out to be a threshold. And what we thought we knew about our place in the cosmos, well, that's been upended entirely. NASA was shocked not because the data was dramatic, but because it was so unexpectedly rich. Every new discovery proved that we've only scratched the surface of what's out there. Space isn't cold and dead. It's dynamic, reactive, alive in its own quiet way. And perhaps more humbling, the farther Voyager travels, the more it reminds us just how much we don't know. But even as its instruments begin to power down and its voice fades into the cosmic background, Voyager has already done something immortal. It has changed how we see the universe and how we see ourselves. In an age of fast news and faster distractions, it's given us a long, slow lesson in patience, persistence, and perspective. Soon, both Voyagers will fall silent. There will be no fanfare, no fireworks, just silence once again. But they will keep flying, untethered, eternal, carrying the story of Earth with them. A tiny human fingerprint in the vastness of everything. And somewhere, far beyond the edge of our solar system, in the cold and humming dark, the universe will keep whispering. The question is, will we keep listening? That's the end of the video. Thanks for watching, and watch out for our next uploads.